So in this video we're finishing up our section 4.9 with a graphical antiderivative. So graphical antiderivative, we want to figure out, given the graph of the derivative, can we find the original function? So let's just start off. Oops, whoa, that's that's not too good. Okay, let's see. How about if this is my function here? We'll do a couple of little swirls there. And so this is x, and this is f prime of x, right? And so the question is, can we find the graph of the antiderivative? And so if we think about it, probably the easiest place to start is where the derivative is equal to 0. So at these three places, the derivative is equal to 0. And so that means that locally, the graph of f of x is going to be a little flat line, right? The problem is, like we saw in the algebraic antiderivative, was that we don't know what the plus c is going to be. And changing the c changes the position of the function, right? And so one way to get around that is I just draw like a flat line all the way through, like along a vertical column here. And so I know that the function is going to be flat here, but I don't know where it's going to be flat. And so similarly, at this point I know the derivative is 0. So I'll go ahead and put some horizontal lines in here. Okay, and similarly here. So I don't know where the function goes through this x value, but I know that it should be flat when it does. Very good. Alright, so what are some other things that I know about my function here? Well, where the derivative is positive, that means the function is increasing, right? So how much is it increasing? Well, let's see. Well, suppose that this is 1 here, right? That means that along this axis, then, the local slopes here would be 1. Oops, that's kind of steep for 1, isn't it? Oops, there goes my axis. Let's see if I can draw that. And so a 1 is kind of at 45 degrees. Oops, oh well. You'll draw a better one than I did. Okay. And then let's see. Let's suppose that this is a -1 here. And so that would give me slopes along this way, right? And then similarly here, this is a little bit bigger than 1, maybe 2, so I'll try to draw a little steeper line there. Those are slopes of 2. And then down here again, we have a slope of like -1 maybe. So that's in like the -45 degrees. And so what I'm drawing here ends up being what's called a slope field. That is, I'm drawing where what the derivatives should imply about the original function, but I don't know where the function goes through. Okay, but I do know that whatever my function is, my original function, it should be consistent with these local slopes, meaning these local slopes should be equal to the local tangent line to the function there, right? So my function, for example, would not come through and like cross one of these like that, right? It has to be consistent, meaning the graph would have to come in like this, right? Good. Okay, let me put that back in there. Okay. So let's go ahead and just see if we can draw a sketch of a function that's consistent with these. Let's see, maybe green. So this is going to come up. It's going to flatten out here, and then we're going to come down here. And notice that this is the steepest negative slope here, and so then it's going to come back around, and then this is the steepest positive slope here. So that's the steepest positive, and then it kind of flattens out there, right? And then it comes back down. But now, yeah, the local slopes are staying at about -1 or so, so that's just going to keep coming down here, right? Okay, so this green curve then would be an example of what the original function would be. But of course you don't know where it goes, so let's draw another one. here's another possibility, right? Or here's another possibility. Good. And so you see what's happening? This is just shifting the function up and down. Good. And so there's lots of possible antiderivatives for this function. Now, just to review what we did, if you're trying to draw the graph of an antiderivative, I like to start with the zeros of the function and then look at where things are positive and negative from there. Okay, so let's try another one. Maybe that's even simpler. I'll pause here for a second and we'll give it a try. Okay, so here's a fairly straightforward function here. My f prime is just kind of like a straight line. What would the antiderivative look like for that? Let's see. So, like last time, this is supposed to be 0. So I know that the slope is going to be 0 there, but I don't know where it's going to be 0. Right? And so let's see. About this point right here, let's say this is 1. And so this would be a slope of 1 here. So my local slopes would have a local slope of 1 here. Looks like they'd match up right there, huh? And then back here, this is about -1 slope, right? So that would come down like that. Oops, I'm getting too steep. It's hard to draw those. Oh no, I lost my derivative. Oh well. Let's draw that back in. Okay, and so do you kind of see what kind of a picture we're going to get? You probably could have guessed. It looks like parabolas. Yeah. Good. And so here's my antiderivative. Right, and so really you can kind of tie this up with the or the algebra. So if f prime of x is equal to x, right, then f of x would be x squared times 1 over 2 plus c. And so that's what you're seeing here. These are our parabolas shifting up and down depending on what the value of c is. Excellent. All right. So there's more of those in the book. I encourage you to take a look at those. They're kind of fun to do, and you might see a couple here and there as we go. All right, I think we'll stop there, and I'll let you work on the homework. See you later.